Alright, so let's crack straight on to question 3. So we're going to be looking at the photoelectric effect here. So first question, what is the meaning of the word threshold frequency? So the first thing we should talk about, so it's the minimum frequency. And it's the minimum frequency to cause an emission, to cause a photo emission, so a photon to emit an electron, from the surface of a material. So some key things in there. So we've got, it's the minimum frequency to cause a photo emission from the surface of a material. So that's the complete definition. Actually, in this question, they weren't that interested in you writing it on the surface of material, but they usually are, so make sure you're writing it. Okay, so we wanted to calculate the work function. So work function is h times the threshold frequency. So it would be 6.63 times 10 to the minus 34, that's Planck's constant. Threshold frequency, you can see from the diagram, is 4.85 times 10 to the 14, because that's the first frequency at which you get an emission. And let's type that into the calculator and see what we get. And we get a number, when we round it, would be 3.22 times 10 to the minus 19 joules. Okay, so the next question wants us to convert that into electron volts. So we know an electron volt is 1.6 times 10 to the minus 19. So we can see this number here we've got is approximately double 1.60 times 10 to the minus 19. So we're expecting something around 2. But let's actually do the calculation. So we've got 3.2155, so using the unrounded number, times 10 to the minus 19, divided by 1.60 times 10 to the minus 19, so they cancel out. If we type that in, we end up with a number of 2.01 EV when you round it to 3 significant figures, which you should, because the numbers you're using in the question are 3 significant figures too. So we're exchanging metal A for metal B, and it has a work function half that of metal A. So if it has half the work function, it would therefore have half the threshold frequency. So let's sketch what that looks like. So the gradient of this graph, we have a look at that. This is the equation of the graph. So the gradient is Planck's constant, so we'd expect to have the same gradient, but half of the, essentially this. So this would be like 2.425, blah, blah, blah. So it would be exactly half the threshold frequency, and the gradient should be Planck's constant, the same as this one. That's a bit of a rough sketch, but you should be showing the same gradient. Okay, so at a fixed frequency, the electrons are collected and the current's recorded. So current would be the number of photoelectrons per second. State and explain a change that may be made to increase the current. So one of the key things that you should know about the particle model is the way to increase the number of emissions per second is to change the intensity. So that's what you're going to do. You're going to increase the intensity. And so in terms of explaining what that means, it means there's more photons incident per second. So you've increased the rate of photons. Or you've got more photons incident per second. And in terms of explaining how that works, each photon has a 1-to-1 interaction. So each photon interacts with one electron. So if you have more photons and they interact through 1-to-1, that gives you more electrons per second, which would be, which is essentially the current increasing. So the stages that you're looking for, that's stage number 1, so statement number 1, statement number 2, so what intensity is, And then lastly, the fact that one-to-one interaction means more photons gives you more electrons. That's the stages you need to be thinking through there, and that concludes question 3.